Alright, time to get back into that subject we all know and love, chemistry. Chapter 10, starting with the problems in the book. 10.1 through 10.5 is basically asking for the names of these things, like knowing that HCl is hydrochloric acid. I don't think you're going to need to know that, so I'm going to not worry about that. And if you do need to worry about that, I'll ask Bryson, and I'll put the video up later, if it actually matters. Let's start with 10.9. No, let's do 10.8. 10.8. Identify the reactant that is a Bronsted-Lowry acid and the reactant that is a Bronsted-Lowry base in each of the following. Okay, so Bronsted-Lowry is pretty much always what we're going to be dealing in. Don't even worry about it. So 10.8. Here's our reaction. We have CO3 2-, which means it has a -2 charge, plus H2O. This is aqueous, by the way, and I'm assuming that's liquid. Yeah, liquid. Has to be. That's aqueous. Yields equilibrium reaction. Yields HCO3 negative. HCO3 negative, and OH negative. I think those are both aqueous. Yeah, both are aqueous. Alright, so when we're dealing with Bronsted-Lowry definitions, which is pretty much what we'll always be in, an acid, the rule is an acid donates or gives away the H+, aka the proton or the hydrogen, whatever you want to call it. This was on the board last video too, so make sure you know that. And also these two things I'm writing here, base and acid. A base accepts the H+. So drill these things, like pause the video, drill these things right now, make sure you know them, because you're going to need to, obviously you're going to need to know that for the quizzes and this problem right here. So we're asked to figure out what is the acid in this and what is the base. So let's see what actually happened in the reaction to figure this out. You have CO3 2-. So let's go over here on the other side of the formula after everything's already reacted and find our CO3. You find our CO3 right here, and it actually gained a hydrogen, so it accepted it. And let's see down here, yes, a base accepts H+. So this is the base. And that means that the acid donates its H+. So in this case, this water molecule gave away one of its H's and turned it right here. And that means that all that's left is HO. Pretend it's just HO because it gave that one H away. And this is that. It's called OH negative, but it's basically just HO. And you see that 2- and the negative? Don't let that confuse you. This is actually very, very easy stuff. So the CO3 is, you're given the charges first off, so it's 2-. And we know the charge on H. It's plus, so just +1. This has a +1 charge. So in this case, it gained 1 H. See, it's over here. It has that H now. It gained the H, which means that its charge has been brought up by 1. So this 2- turns into -1, which is just written as negative. And currently, since this is neutral, this H2O is neutral, it's going to lose a hydrogen, which means it loses 1+ charge, which brings it down to a -1 charge, which is why this gets written out as -1. So you basically just have to know how the hydrogens function and what happens. Basically, whenever you're asked to lock on and figure out what an acid or the base is in reaction, find the what's it called? The base, which usually it's going to be a CO something, it's like an NO4, something like that. You'll know what it looks like, and find it then on the right side and see what happened. Just find whatever got an H added to it, and that'll tell you. Next problem. I'm going to leave that definition there, and hope this board doesn't fall. Because see how this crack is bigger now? Yeah, last night at 2 in the morning, I'm dead asleep. It falls, wakes me up. I crap my pants. I'm terrified. It was just a bad night. All right, time for the next one. H2SO4. I'm not going to write aqueous or anything just because it doesn't actually matter for this right now. I know the real chemist people out there are going to kill me for that, but I'm not a real chemist. Like we all know, I'm an English education major. I don't care about the science. I just want a good grade, as we all do. I'm starting to ramble. I'm going to stop talking. Okay. And this is actually not a reverse reaction, sorry. Not equilibrium, so it's not happening back and forth. It only happens once, and that's it. So, let's see what happens in this reaction. We have H2SO4 and an H2O. Now it turns into H3O and HSO4. So, what gained a hydrogen? This is pretty easy. We have H2O, and then it turns into H3O. So obviously this is what gained the hydrogen, or proton. So it gained an H+, and I'm just gonna actually draw this out visually, like I love to do. So we've got an H2O, and it gains a hydrogen by taking it off of this. So this now becomes HSO4. And it gets a negative charge because over here, it was neutral. There's no plus or negative. So that means if you take away one of its charges, then it's going to become negative. So -1. And this the H2O is what gained that hydrogen that was taken away. So it becomes H3O. So what would the charge on this be? If it's neutral over here and it gains a proton or a hydrogen, those are the exact same thing. Boom. Then if it gains that, it'll have a +1 charge. So H3O plus. There you go. That's that explained. If it doesn't make sense, you can always text me. We all have my phone number now, I hope. If not, just watch the other video I put up. Alright, next problem. Let me see here. Write the formula and the name for the conjugate base for each of the following. Okay, so we have HF. We have H2O. We have H2CO3. We have HSO4. Whoops. Don't know why I was writing that as a subscript. That's not how it works. HSO4, negative. And then all the other charges are already neutral. So, what is the definition of a base? I'm going to rewrite the definition of an acid and a base and what they do. Acid donates donuts. I love donuts. Donates H+, and then a base accepts H+. Just one H+. So the question asks, write the following name and the conjugate base for each of the following. So we're asked to give the conjugate base. So that means that these are already acids, right? Because they already have their hydrogen. So since they're turning into conjugate bases, we have to give one of the hydrogens away because these are acids. And we can infer that these are acids because it's asking for bases. So one has to be base, one has to be an acid. So what happens when you give this H away? So we have F. That's all that's left, right? Right. Just an F. But since this is neutral charge, it's going to go down to a -1. This will, if it's not making sense, just keep watching me work through these. They'll start to make sense. It'll click. So H2O. Since it's turning into a base, it has to give away an H+ or donate it. So it gives away it loses its H and turns into OH because it lost, it'd be OH2 if it had the other one, or H2O. But since it lost, it becomes OH, and then that charge drops down to a -1 because it was neutral and then lost a plus charge. So now we have this one giving away its hydrogen, and it's H2CO3. I'm going to double check just to make sure these are all right. I'm pretty much positive they are. If they're not, I'll have to restart the video and do everything I just did over and over again. Let's hope they're right. Although I can pretty much assure you they are. Answers. Come on, give me the answers. 10 point, let's see here. I mean, what number this is. And I didn't write it down. Fantastic. 10.9. H2SO4. I'm on the wrong problem. 10.9. Oh, sorry. I was looking at the wrong thing. Here we go. 10.9 FH, OH negative, HCO3. Okay, yeah. Sorry, we're good. Sorry about that. I'm just double checking here. Okay, so since this is going to be giving away one of its hydrogens, because it's an acid, that's what they do. Acids give away hydrogens, bases accept them. So it's going to turn into H, since it's no longer H2, since it gave one away, HCO3. And since it's neutral and loses a plus charge, it becomes -1. Hope that's starting to click. Now we have HSO4 minus. So that has a -1 charge. So we're going to take away one of these hydrogens, or the only hydrogen, which means that this -1 is going to go down another charge. So it becomes SO4 because it lost the hydrogen, so it's no longer H. And it's going to be -2, or 2 minus. And that's the charge on that. Awesome. Next up, let's do 10.11. Write the following name of the conjugate acid for each of the following. Alright, so now instead of going from an acid to a base, we're going to go from a base to an acid, which means that we're going to accept an H+, and go up a charge. So let me write out what we have. It's 10.11. That last one was 10.9. Yeah, 10.9, by the way. So we have CO3, 2 minus, which means -2 charge, H2O, H2PO4, and SO3, 2 minus. Alright, so in this case, we are accepting a hydrogen, as in we're going to gain one. So in that case, our charge will go up 1, and we'll just draw an extra H on there somewhere. So CO3, 2 minus, it's going to become HCO3 because it's gaining a hydrogen. HCO3, and since it's -2 charge, it's going to go up 1 charge. So it becomes HCO3 minus. H2O is going to gain a hydrogen, so it becomes H3O. And that's +1 because it's going from neutral, gaining a plus charge, so it becomes +1. H2PO4 negative, it's going to become just H3PO4 because we're adding a hydrogen or a proton, whatever you want to call it. And then it's going to be a neutral charge because it's bringing a negative up to a 0. Now we have SO3, 2 minus, and that's going to be HSO3. And then it should be minus because that -2 is brought up 1. So basically, if it says to write the following name of the conjugate base, that means this is an acid. If it's asking for the conjugate acid, then this is a base, and you need to apply these definitions accordingly. So if it says to give the name of the conjugate acid, that means you're dealing with bases. So you're going to be adding an H, like we've been doing here. Check in the book. These answers are all right, I promise. So that should cover this. I'm going to get into more difficult problems as the videos progress, but this should keep you occupied for a little bit. Just make sure you understand how the H's work and how the charges work. That's the most important thing. I'm pretty sure Bryson's not going to ask you about naming these things. I mean, that's unlike him. So he's going to ask us curveball questions that we have no idea what they are.